we'll be discussing dark energy! Our universe is made up of matter and energy, and lots of it too.
However, only 5% of this is normal matter, or the more appropriate term for it would be baryonic matter.
Baryonic meaning massive particles like protons and neutrons that are consistent of 3 types of basic particles or quarks. But what exactly is the remaining 95%?
Let's go to the pie chart, because that seems to be a popular concept.
Only a measly 5% of the stuff in the universe is made from matter.
So dark energy makes up 69% of the energy density in the universe, and 26% is dark matter, and about 5% is baryonic matter.
It looks like this. 95% of the universe is made of stuff we can't directly see.
Approximately 68% of the universe is made up of dark energy, and about 27% makes up dark matter. In 1933, the Swiss-American astronomer Fritz Zwicky first discovered dark matter's existence. He detected that the mass needed to keep galaxies from escaping a cluster's gravitational pull in the Coma cluster was not equivalent to the mass that was expected.
In the 1970s, American astronomers Vera Rubin and W. Kent Ford discovered a similar anomaly. 90% of the mass required to keep a typical galaxy in orbit is absent visually.
Therefore, the luminous galaxy cannot determine the entirety of the substantial mass of the galaxy. The answer? Dark matter!
Dark matter is matter, physical substance, atoms, and other stuff, that is undetectable at any wavelength in the electromagnetic spectrum.
Also known as the dark halo, the implied halo of imperceptible particles that encircles individual galaxies and stars.
There are a few theories as to what dark matter actually is. Theory 1 explains it as a grouping of massive astronomical compact halo objects, or MACHOs, which are types of non-radiant supercompact objects like black holes, faint stars, neutron stars, brown and white dwarfs.
These objects exude little radiation. As a result, they are nearly undetectable, therefore making them an acceptable explanation for the lack of mass in our universe. However, the MACHOs are only capable of explaining 20% of the galaxy's dark matter. The remaining 80% is still unaccounted for.
Theory 2 states that the 95% of invisible matter is composed of WIMPs, weakly interacting massive particles. These particles don't behave like normal baryonic particles. In fact, they are electromagnetically indifferent and don't produce light.
Conceptually, about 100,000 WIMPs would pass through every single square centimeter of the Earth every passing second, only interacting with weak force and gravity.
In South Dakota, a facility called the Lux experiment was created to detect WIMPs passing through the Earth. The experiment began with a vacuum thermos filled with ultra-pure liquid xenon, cooled to negative 160 degrees Fahrenheit, that is placed into a tank of water. Then, photosensors detect interactions between photons to find any evidence of dark matter.
A particle considered to be a sort of WIMP is an axion. They have yet to be encountered, but the axions represent what astronomers believe dark matter would act like.
Axions do have mass. In large amounts, they would have enough gravity to influence galaxies.
Emit little to no light, also making them similar to properties of dark matter. Furthermore, the axions don't interact with normal matter much at all.
An axion could pass through you or me as if we did not even exist.
Because of this, they are super difficult to detect and are ultimately invisible to experiments such as Lux. Yet no WIMPs or axions have been discovered, therefore this theory is inconclusive.
Theory 3, and the final theory, states that Isaac Newton's law of gravitation and Albert Einstein's theory of general relativity may have been false.
False.
Newton's law says that the gravitational force between two bodies is proportional to the product of their masses. His law must be adjusted to accommodate for the dark matter surrounding the galaxy, so that as mass is increasing, the gravitational force is simultaneously increasing at an exponential rate.
Astronomers observed the orbit of 2 galaxies. They calculated the mass of both galaxies and found that the masses, according to Newton's law, should not have been enough to hold them in place.
Alas, the galaxies continue in their orbital path. So where does this extra gravitational force come from?
You guessed it! Dark matter!
In 1915, the famous scientist Einstein concluded that massive objects warp space-time.
The gravitational field of massive objects allows for light rays passing close by to be bent and positioned elsewhere.
The term for this effect of mass on light is gravitational lensing.
Utilizing Hubble's advanced telescope, scientists were able to identify the dispersion of dark matter by means of gravitational lensing.
This is an image of the bullet cluster.
The red area depicted in the cluster is X-ray radiation from the hot gas.
And the blue is the predicted dispersion of dark matter after the collision of the 2 galaxies.
Because this area is causing a gravitational lens distortion, it is evident that something must exist there.
It's dark matter! But dark matter is not the only culprit of confusing theories.
It's halftime! Hey Heidi,
Hey Hannah,
how do you throw a star party?
I don't know, how do you throw a star party?
You plan it.
Einstein developed a theory about space, and it was about time too.
In early speculation of the universe, astronomers believed it to be static, or remaining the same size.
This was troubling to Einstein since he estimated that the force of gravity would cause a collapse of the totality of the universe.
Einstein added the cosmological constant, this being the first theory relating to dark energy. However, in 1930, Edwin Hubble discovered the universe was not in fact static. It was expanding at an accelerated rate.
The universe itself is expanding.
And that meant something truly shocking. The expansion of the universe was accelerating. Now remember, that's nuts.
The fast expansion of the universe is hypothesized to be directly related to an unknown source of pressure. Which brings us to our next topic. There are several theories that contribute to the ideology of dark energy. The second theory states that dark energy is a mere property of space, pertaining to empty space. Using vacuum energy, empty space is able to generate more space. As the universe expands, the generated space fills the gaps, leading to a faster expansion of the universe.
Vacuum energy is representative of negative pressure outward because it is constantly generating and filling in more space to provide an explanation for the quickly expanding universe.
The possibility of the existence of quintessence. Quintessence is the derivative from the medieval Latin word meaning fifth essence or fifth element, because according to medieval philosophers, there are 4 common elements in the universe: earth, water, fire, and air. Quintessence is known to be the 5th.
It is a unique sort of energy that forces atoms away from one another and defeats gravitational power, making it a good candidate for dark energy.
That's just a theory.
An astronomical theory.
And that's a wrap, ladies and gentlemen.